Hello my dear students and my dear friends. We are in the chapter plane geometry and this is the second part of exercise 8.2. Okay, here we have again started with question number 6. Let us read the question. In the first part of exercise 8.2 we have done one theorem as well as from question number 1 to 5. And in the second part we will start from question number 6. Let us start the question. Let us read the question. The internal and external bisector of angle A of triangle ABC meet BC and extended BC at D and E respectively. Prove that this. Okay. Let us draw the figure at first. Okay, I will draw in the freehand diagram. Okay, suppose this is triangle ABC. Okay, intentionally we have drawn in this shape. If we draw in this acute angle triangle, the diagram will not be so nice to solve this sum. Okay, you will see. So here at first, what is the internal and external? Okay, that means we have to draw both the bisectors. Okay, here at first let us draw the internal bisector. Internal bisector means BC at D. Okay, that means these two angles are equal. Then external bisector. So let us draw the external bisector of this angle A. We have to produce it also. This external bisector means BC at E when we extend BC at E. That means these two angles are equal. Okay, let us put a name A, B, C, D, E. We have used F. Okay, this part is given. I am not writing the given part. Directly I will move to the proof part. That means these two angles are equal, these two angles are equal. Okay, so let us write from to prove. Okay, given part you can easily write. What to be proved? BD by BE is equal to CD by CE. Got it? Okay, let us start from proof. Proof is very easy. Okay, you see. Here at first let us recapitulate whatever we have done in triangle ABC. If AB is the internal bisector, that means these two angles are equal. Then what we have? AB by AC is left right, then here left right. BD by DC. And if it is the external bisector, A, B, C, if external, sorry, not this one, external bisector, I will write this. If this is the external bisector, okay. Suppose this is E. What we have? This AB by AC is equal to this BE by CE. This part you have to know. In the first part of this video, we have done it nicely. Okay, this was the theorem and this is question number 1. Okay, it doesn't look good. Okay, here. So we'll use this. This question is actually the application of both this property as well as the theorem. Okay, now since AD bisects angle BAC, so what do we get? What do we obtain? We obtain that AB by AC left right equal to left right. AB by AC equal to BD by BC. Have you understood? Okay, let us move. AB by AC, sorry, this is AC and equal to BD by DC. This is say equation 1. Okay, this is done. Again, let us move for this. A is the external bisector of angle CAF. Also, what is that? AE. AE bisects angle CAF. So, what we obtain? Let us apply this property. That is again AB by AC. AB by AC. Okay, then AB by AC, you forget this. Okay, for the time being you forget it. This is the bisector. So AB by AC equal to BE by CE. Let us write down. Okay, BE by CE. This is equation 2. Okay, from equations 1 and 2. what do we obtain? You see, here in equation 1, the left hand side is AB by AC. Again in equation 2, the left hand side is again AB by AC. So they are equal. If equals, these two are equal, so they are also equal to each other. Okay. So therefore, what do we get? BD by DC. This is equal to this. What is that? BE by CE. Now let us see what we have to prove actually. We have to prove this BD by BE. So this BD let us write down, and this here, this B we have to bring here. Okay, that means this is the case of cross multiplication. This into this equal to this into this. Their product will remain same. But this B can be easily brought. If we have brought here, so this DC we have to take there. This DC they have written as CD. DC and CD is same thing, no issue. CD, and this is CE. Again I am explaining, this BE is brought here. This DC is taken there. And DC on the other side we have written as CD. Okay, so this is the demand of the question. So thus we can write, we have proved. You see, the solution is so simple. Now my beloved student, we have taken question number 7. Here the solution is very simple. At last, before solving, let us read the question. O is the point in the interior of triangle ABC. The bisectors of angle AOB, angle BOC, and angle COA meet AB, BC, and AC at D, E, and F respectively. Show that this. Okay, do not get scared seeing this expression. This is very simple, believe me. Okay, at first let us draw the triangle. Okay, here this is the triangle. Okay, let us draw a little bit bigger. Okay, it is okay then. Name of the triangle is ABC. ABC. And O is a point. This is point. At the end we'll mark O there. Then what are these? Angle AOB. Okay, this is, let us mark AOB, and this another angle is AOB we have marked. Then BOC, this is BOC. Then another angle is angle COA. Then the bisectors of angle AOB. This is the angle AOB. Suppose this is O here. We have marked. Okay. Now the bisectors of angle AOB. This is angle AOB, it is bisected somewhere here. Okay, let us draw it by dotted line. This bisector, all the bisectors we have drawn by dotted line, so that we can easily distinguish that this is the bisecting lines. Okay, you can draw solid line by here, but here, as I have shown in the showing in the board, to distinguish, we are drawing the dotted line. Okay, again I am telling you can draw solid line, no issue at all. So these bisectors meet AB at D, AB at D, then BC at E, and AC at F. Okay, that means this angle equal to this angle, this angle equal to this angle, this angle equal to this angle. This is given. What we have to prove? We have to prove this. So let us write to prove. This is very simple. You will find AD into BE into CF is equal to DB into EC into FA. Okay. Now let us start the proof. We shall use only the one theorem, the theorem which we have in exercise 8.2. That is, if a line bisect this vertical angle, okay, then AB by AC is equal to this by this. That is BE by CE. This concept we shall apply. Now here at first you see what is given, the bisector of angle AOB. AOB, this angle. Okay, I am drawing one triangle. I am drawing so that you can easily understand. Okay, this base is AB. It is base is AB. This base is AB, and this is the point O. This is bisector at D. That means these two are equal. So what can we write? This by this is equal to this by this. AO by BO is equal to AD by BD. This concept let us apply. Okay. In triangle AOB, OD bisects angle AOB. So what do we obtain? Therefore, two ratios are equal. Which ratios? Here we have AO by BO is equal to this by this. AO by BO is equal to AD by BD. Let us write AD by BD. AD by BD. This is equation 1. Okay, this same concept we have to apply 3 times. Once we have applied, another we shall apply this concept, we shall apply in this triangle. Again we shall apply the same concept in triangle AOC. Got it? Again, in triangle BOC, OE bisects angle BOC. This OE bisects this angle. That means these two angles are equal. So what we have? BO by CO is equal to BE by CE. Okay. Same concept. We can change the name. Okay, we are changing the name. So here it is BC and it is E. So let us write. So BO by CO. BO by CO. Left right. BE by CE. Correct? Equation 2. Now one more triangle. This triangle is left, isn't it? Also, in triangle, that is AOC, isn't it? Yes, AOC. This OF bisects. OF bisects angle AOC. So what we obtain? Let us change the name of the triangle. What we have now? This is AC. Okay. Let us write C here and C here, A here. Why? Because we are maintaining some order. At first we have started this AO, then BO. In the next one, you see, if you do not understand, AO by BO in the next triangle, we have started from this BO by CO, and in the next triangle, what will do? We shall again start from this CO, isn't it? This CO. So there is a reason why we are maintaining this order. Okay, so what will write? CO by AO is equal to this. Okay, I have not given name here. This is CF by AF. This is equation 3. Okay. Why we have maintained this order? Because now what we'll do, we shall take the help of equation 1, 2 and 3. Okay. Then you see, we shall multiply in these 3 equations. In the process, what will happen? This AO and AO will get cancelled. BO, because AO is in the numerator, if this AO is in the denominator. Okay, then BO is in the denominator, this BO is in the numerator, like this. For this reason, we have written in this order, so that we can cancel, because our aim is to prove that the product of this numerator is equal to product of the denominator. For this reason, we have to cancel out the left hand side. I hope you understood. Now what we do, let us wrap this. Now, students, we should write from equations 1, 2 and 3, we get, what we do, just let us multiply. Left hand side into this left hand side is equal to right hand side into right hand side into right hand side. AO by this BO, this BO by CO, then this CO by AO. CO by AO is equal to 3 ratios we have to consider. 3 ratios. AD by BD. Next is BE by CE. Next is CF by AF. Alright. Now dear students, you can see we can cancel this. So this is 1. That means we can write direct like this also, so that we can understand easily. This is AD into BE. We are multiplying the numerators. This is very easy for us now. BD into CE into AF. Now let us cross multiply. Okay, they are equal. So this into this equal to this into this. What we have to write? At first AD into BE. That means this into this one we have to write. AD into this BE into CF is equal to. So this into 1 is same thing. This into this is same thing. Here what we write? That is BD into CE into AF. Now let us see whether we have got it or not. AD, BE, CF, DB, EC, FA or AF, same thing. So just we can write here, we have proved. Have you understood this? Next, my dear students, we have taken question number 8. Let us read the question. The bisector of the right angle A of the right angle triangle ABC cuts BC at D and the perpendicular from D cuts AC at E. Prove that this. Okay. Let us draw the triangle at first. What type of triangle it is? It is right angle triangle. It is set. That means angle A is 90 degree. We have to draw. Okay. We have drawn angle. It is 90 degree. Angle. This angle is 90 degree. Angle A. BC. If you want, you can draw in this triangle also. No issue. Then the bisector of the right angle. Okay. This is the. Now let us draw the bisector. This is D. The bisector of the right angle A of the right triangle, that triangle ABC cuts BC at D. Okay, then the perpendicular from D cuts AC at D. Let us draw a perpendicular here. Okay, this is perpendicular, cuts AC at E. This is E. Okay, this is perpendicular, this is perpendicular. So easily we can understand that they are parallel lines, because in a line, suppose this is in on AC, there are two lines. This is one line and this is another line. They are perpendicular. So they are obviously parallel to each other because they are corresponding angle. If two corresponding angles are equal, then the two lines are parallel. Okay. Now, what we have to prove? To prove DE, let us write this part. DE into AB plus AC is equal to AB into AC. Here also the proof is very simple. Very simple. But there are two steps, you will see. Because you can easily say that there are two steps, one for this, another for this one. Okay, let us see. What is AD? AD is the bisector of this angle. That means this angle is equal to this angle. In triangle ABC, AD bisects angle BAC. So what we obtained, AB by AC is equal to BD by DC, this whole thing. Therefore, AB by AC is equal to BD by DC. Okay, this is by the theorem. Okay, dear student, but here you see, we need AB plus AC, but we have got this. So to get AB plus AC, what we do? We can add 1 on both the sides. We are adding 1 on both the sides. Why? Because we want to obtain. How can we obtain? You see, let us take the LCM. What is the LCM here? AC. So it is AB plus this AC. And here this is DC. This is LCM. So DC by DC is 1. 1 into BD is BD. DC into 1 is DC. Okay. Here AB plus AC divided by AC. Now what is BD plus DC in this diagram? Let us add them. This BD plus DC is BC. Let us write this BC by DC. This is equation 1 because we cannot do anything further. Okay. Now next, what is given? You see, directly also we can do, or you can show also that this triangle ABC and triangle EDC, they are similar. Why? Let us turn the triangle so that you can understand. Okay, triangle ABC. Okay, this is A, B, C. No, let us write in this way. C. Okay, here let us give. You can easily understand now. This is E and this is D. This diagram is easier, I think. C, this is A, this is B. Correct? Yes, this is the triangle ABC and ED. Here, this angle is 90 degree, angle A is 90 degree, and angle E is also 90 degree. Here, it is not 90 degree, but it is 90 degree in the figure. So with the usual figure we are doing. What is my intention? My intention is to show that these two angles are equal. Okay, actual diagram is this. Okay, now Here, if these two angles are equal, by 90 degree, 90 degree, and this angle is common to both the triangle EDC and triangle ABC. So as this angle equal to this angle is for the smaller triangle, this angle for the bigger triangle, both are 90 degree. Again, this is common to both the triangle. Hence, these two triangles are similar by angle similarity. Have you understood? Again, I am repeating. In this smaller triangle and bigger triangle, these angles are equal. You see, if we want to show that two triangles are similar, we have on the basis of angles, we have to show that two pair of angles are equal. One pair is this angle equal to this angle 90 degree, and another pair is this is common angle. This angle is common to both the smaller triangle as well as the bigger triangle. So directly we can write. If you want, you can show also. This proving is very easy. You can easily do. I am not going into that. Also, triangle ABC is similar to triangle ABC we have written. So in this order we have to write EDC. Triangle, sorry, let us write triangle. Okay, triangle is written EDC by angle similarity. Okay, now if these two triangles are similar, here also you can see, if these two triangles are similar, that is AB by DE, this AB by DE is equal to what we need? We need this BC by DC. Then this bigger part BC by DC. Okay, we know that if two triangles are similar, then the corresponding sides are proportional. Corresponding side of the equal angles are proportional. So we have written AB by DE, then this side by this side, BD by BC by BD. You can write BC by DC. I hope you understood this. This is in general mathematics also you got this. So I am not going to deeper into this. This is equation 2. We have obtained equation 1 and equation 2. Now you see, dear student, this BC by DC, here it is BC by DC, here also BC by DC. So they are equal. What we will do next? We shall write them equal, because this part and this part, they are equal to BC by DC. For that we have to drop this part. Then my beloved student, from equation 1 and 2 we shall write that they are equal, because each is equal to BC by DC. From equations 1 and 2 we get, what do we obtain? That this AB plus AC divided by this AC is equal to this AB by DE. But my dear students, what we are asked to prove? We are asked to prove this DE into this. So we have to multiply. That is, here you see, the thing is very simple. This will be our final statement. Just what we have to do? We have to cross multiply. So this into this or this into this. DE into AB plus AC is equal to AB into AC. According to this, AB into AC. Thus we have proved it. Okay, my dear students, we have taken question number 9. The bisectors of angle BAC or triangle ABC called BCFD. If the bisectors of angle ADB and angle ADC cut AB and AC at P and Q respectively, then prove that this. Okay, here also you will find the solution is too simple. Okay, here what we do? Let us take the triangle. Name of the triangle is ABC. This is A, this is B, and this is C. The bisector of angle BAC cuts BCFD. Okay, this is D. That means these two angles are equal. After that, if the bisector of angle ADB, okay, this is angle ADB. If this is bisected, ADB and ADC, okay, let us draw both. That means this angle is equal to this angle is equal to this angle. Okay, AP and cut AB and AC at P and Q respectively to prove this. Okay, let us start from to prove. What we have to prove? AB into AP into QC is equal to this AC into AQ into PB. This is we have to prove. Okay. Now let us start the proof part. Proof part is very simple. Just we have to use the property that this line bisect this angle. So this AB by AC is equal to BD by DC. Right? Let us see. Let us apply from the first one. This AD bisect angle A. There are three angle bisectors. We shall use 3 times the same theorem or same property. In triangle ABC, AD bisects angle BAC. So what we obtain? AB by this, AB by AC is equal to BD by DC. Alright? This is equation 1. Okay, after that, in next which triangle? Triangle ABD. Okay, let us write like this. This is a triangle. This is angle bisector. Let us write DAB. This is P. This is the bisector. DP is the bisector. That means these triangles are equal. So also in triangle ABD, DP bisects which angle? Angle ADB. Angle ADB. So what we obtain? Therefore, we obtain this AD by DB, AD by this DB is equal to AP by PB. AP by PB. Now dear students, I have a request. Just we shall change the side. They are equal, these two are equal, so we shall write like this. If this equal this, we can write this in the left hand side. Now there is a reason why we are writing AP by PB. This one we have written at first is equal to this AD by DB. At the end I will tell what is the reason. Just you listen now that we have to write like this. Okay. Again, one more is there. What is that? This triangle DQ. DQ bisect this angle. What is this? C and A. This is C and A. This angle DQ is the bisector. That means this by this equal this by this. Again, in triangle CDA, DQ bisects angle CDA. Angle CD is CDA. Angle CDA. So what we obtain? Two ratios are equal. This by this, CD by AD is equal to CQ by AQ. Left, right, left, right. CD by AD is equal to CQ by AQ. Now, here also, we shall change the side. This equal to this, we can write this equal to this. CQ by AQ is equal to this. CD by AD. This is equation 3. Okay. Now what we will do? We shall obtain what we get from. We will obtain from equation 1, 2, and 3. You see, why we have changed the side? There is a reason. What we have to prove? We have to prove that the product of this equal to product of this. That means somehow we have to multiply. We have to get AB, AP, and QC. If we multiply these three, BD and DC, in the first equation we have written on the right hand side. So that BD is here. So it should, if we multiply these three results, again what will be the problem if we do not change the side? This DB is in this side, not on the right hand side. This part should be on the right hand side. That's why we have changed. Again here also, this AD and this AD. This AD is on the right hand side, this part here AD is on the left hand side. So we have changed the side. What will do next? I think you are understood that why we have changed the side. Okay, changing the side is not a big deal or big issue. We shall write from equation 1, 2 or 3 we obtain or we get. What we will do actually, we shall multiply these 3. Now let us see what result we obtain. Now from equations 1, 2 and 3 we get, let us multiply these 3. Left hand side into left hand side into left hand side. That is AB by AC into this AP by PB, AP by PB, next is CQ by AQ, CQ by AQ is equal to 3 ratios, multiplication of 3 ratios. What are the ratio? First ratio, BD by DC, BD by DC. Next ratio, AD by DB, AD by DB. Next ratio, CD by AD, CD by AD. Now what you see? What do you observe? AD cancel, DB BD cancel, DC and CD they are same thing. So let us multiply this numerator into numerator. Here we shall multiply like this. That is AB product of this into this into this divided by product of this into this into this. Okay. AP product of AB and AP, then into CQ, this is AC, PB into AQ is equal, this is 1 by 1 we can write so that we can understand easily. What we have to do? AB into AP. Okay, let us cross multiply. Okay, this by this equals this by this, so they are equal. So their product of this into this is equal to product of this and this. So it is AB into AP, this AP, into CQ or QC is same thing. According to demand of the question we are writing, isn't it? Is equal to AC. This AC we have obtained into then is AQ. This AQ into next is PB. This PB. Thus we have obtained the desired result. Is it okay? Now my beloved students, we have taken the last question of exercise 8.2. This here all the parts are very very simple. It is fine. Let us read the question. ABC is a triangle and D is a point on BC. Okay, let us draw the triangle also. The diagram. ABC is a triangle and D is a point. D is a point. The measure of AB, AC, BD, TC and BC are given below. Examine if AD is a bisector. If AD is a bisector. Okay. How will we do? This is the converse of the theorem what we obtained here. Suppose AD is the bisector. If AD is the angle bisector, these two angles are equal. If AD is the angle bisector of angle A, then what we obtain? AB by AC is equal to BD by DC. Here it is the converse. So what we'll do? We shall check if the ratio of this is equal to ratio of this or not. If the ratio of this by this is equal to this by this, then obviously this is angle bisector. If the ratios are not equal, then it is not the angle bisector or angle BSC. Alright, this is the procedure we are going to apply. So let us write here. Number 1, let us do. Here, at first we shall find the ratio of AB. Okay, I have a doubt whether you are understanding. If it is angle bisector, what we should obtain? AB by AC is equal to BD by DC. BD by DC. These two ratios are equal or not, we have to check. Okay, let us find. Here, at first AB by AC, what is the measurement? 4.5 centimeter by this 10 centimeter. Correct? Okay. You can do here also. Let us multiply by 10 to remove this decimal. This is 45 by 100. Let us cancel by 5. 5 9 are 520. That is 9 by 20. And in the second case, that is, we have to show that this ratio, we have to take this ratio, BD by DC. BD by DC. What is BD? BD is 2.5 and it is 4. Let us multiply both numerator and denominator by 10 to remove this decimal. This is 25. 4 into 10 is 40. Let us cancel by 5. 5 5 ja 5 8 ja. Now what do you find? Are they equal? No, they are not equal. Here AB by AC is not equal to BD by DC. So what will we write? We shall write that AD is not the angle bisector of angle BAC. Okay, we have taken one more. Actually, there are four sub part or 4 bits. We have taken 2 by 2. At first, we are taking 1 and 2. Then in next part, we shall take 3 and 4. Okay. Again, same concept, same step again we shall apply. Here again, you shall find this AB by AC. AB by AC. What is AB? 4. What is AC? 3. We cannot cancel further. Then this BD by CD. BD. We are finding BD by DC. BD by DC. What is BD? 3.2. DC is 2.4. Let us multiply the numerator denominator by 10. 32 by 24. Alright, I hope you are understanding. Now let us cancel. Let us cancel by 8. 4 8 ja, 3 8 ja, 4 by 3. So they are equal. Okay, let us write here. So therefore AB by AC equal to BD by DC, because these ratios are equal, each equal to 4 by 3. Therefore AB by AC is equal to AB by AC equal to BD by DC. BD by DC. Hence AD is the bisector of angle BAC. Is it alright? Now let us do 3 and 4. Then dear students, now let us move to number 3. Here again same thing, we shall find AB by AC. AB by AC. What is AB? 16 by 24. Let us cancel by 8. 8 2 ja, 8 3 ja, 2 by 3. Next we have to find BD by DC. BD by DC. BD is how much? 6. DC is not given, my dear students. You see, BC is given. Here this BD is 6 centimeter and this DC is how much? 15 centimeter. Okay, so here we are writing BD. BD is how much? 6 centimeter. We have to write DC. What is DC? 15 minus 6. How much it is? 9 centimeter. Got it? This is very simple thing. Let us cancel by 3. 3 2 ja, 3 3 ja. So they are equal. Okay, so what can we write? Therefore AB by AC is equal to BD by DC. Hence AD is the bisector of angle BAC. So this is done. Now only this is left. Now let us complete the last one, number 4. So here AB by AC, let us write down. AB is how much? 6 and AC is 9 centimeter. Centimeter will get cancelled. Let us cancel with 3. 3 2 ja, 3 3 ja. So this is 2 by 3. Next we have to find BD by DC. BD by DC. What are the things given? Let us. This CD is 3 centimeter and this whole BC is 9 centimeter. Correct? Okay. Now just we have to write the measurement of BD. This is 9, this is 3. So this is how much? 9 minus 3, 6 centimeters. Got it? DC is 3. We can cancel. So if we cancel 3, let us cancel by 3. 3 2 ja, 3 1 ja. So this is 2 by 1. Or simply can write 2. Alright. Now do you think they are equal? They are not equal. This is 2 by 3, this is 2 by 1. So here AB by AC is not equal to BD by DC. Hence, what is the conclusion? AD cannot be the angle bisector of angle BAC. Hence, AD is not the bisector of angle BAC. Is it alright?